Hi viewers, how are you? Hope you are doing well. We will talk about the pump specific speed in this video, and we'll try to understand the difference between lower specific speed pump and higher specific speed pump. So let's start our video. So you can see in this picture the pump having the lower specific speeds are normally radial vane areas, impellers, and once we are moving with higher specific speed number, it starts from 500 going to 15,000. Then the higher specific speed pumps are having with the impeller about which are the axial flow type. So one thing which we can clearly understand from that the shape of the impeller is basically tells by the specific speed number. So what is this specific speed? It is rotational speed required to deliver 1 unit of flowing, producing 1 unit of head. For example, in imperial units, the 1 RPM of impeller would be able to turn 1 GPM of flow rate by producing 1 feet of head. So this is called pump specific speed. It relates to the shape of impeller as we have discussed before, and the performance curve shape. We will talk about how it tells us about the performance curve shape. Okay, so rotodynamic pumps, which are centrifugal pumps, have specific speed. We are denoting NS for the pump specific speed in the range of 4 to 300. This is in metric unit, and in imperial unit it's from 200 to 15,500 numbers, and the optimal efficiency of pump is normally at 40 to 60 number. Okay, so in equation we can say that NS is equal to N multiplied by square root of Q divided by H raised power 3 by 4, where NS is pump specific speed, small n this is rotational speed, and capital Q this is flow rate at best efficiency at maximum impeller dia, whereas H, as we know, is the head at best efficiency with maximum dia impeller. You can see here it's head, not the heat, it's typo. I apologize for that. Okay, so how it affects the shape of the pump curve? We have two pumps curve, one at 1000 specific speed, whereas the other at 10,000 specific speed. So you can see in the pump curve the green line showing the efficiency curve, the blue line showing the head curve, whereas red is shown as the power curve, okay, required for the motor. And we can see here that what are the differences between the low specific speed pump and the high specific speed pump. So for the low specific speed pumps, these pumps can deal with lower flow rate but with higher head. But whereas high specific speed pumps are capable to deal with high flow rate but lower head capability. Similarly, low specific speed pumps, they have the flat curve on the head capacity curve. The curves are normally flat, whereas in the high specific speed pumps, the head capacity curve is more steep. Another difference we can see from this curve is as far as the flow increases, the power requirement also increases in the low specific speed pumps, whereas for the pumps with high specific speed, the power is high at the startup, whereas with increasing flow rate, the power demand is reducing. So in this way, we can say here that there may be motor overloading issue at high flow because the power is high at the highest flow. So the designer should take care of this aspect while the selection of pump and motor. But for the high specific speed pumps, overloading can be the issue at startup. So pump should never be started with discharge valve shut because it's difficult to deal with the high power requirement at the startup. So we should have to take care for this, and we should not start the pump with closed discharge valve. So these are basically the main differences between the low specific speed pump and the high specific speed pump. I hope this is clear understanding to you guys now. If you have still any question, please let me know. We will try to discuss more on this subject. So take care.